So I think I signed a waiver saying that I'm okay to be recorded. If you don't want your questions recorded, whisper them softly, just answer them publicly. So hello everybody, welcome. Thank you very much for coming down to the Deep Dungeon on the first day of ICAPS workshops and tutorials. I do appreciate you being here. I was a little worried when I first proposed this that there'd only be 2 people in the audience. My parents couldn't make it, unfortunately. So today I'm going to talk about the Planning.Domains initiative. This is roughly what the outline is going to look like. I'll spend 5 minutes just sort of going through what the Planning.Domains initiative is and the different parts of it. And then a larger amount of time on each of the 3 main parts of it, the API, the solver, and the editor. After that, we'll have a roughly 5-minute break, probably less because I tend to ramble and we'll run out of time. But a quick break in case you want to skip sessions or other people want to come in. And from that point, the second half, we're going to put it all together and create a plugin for the editor.planning.domains, which sort of pulls in different parts, not so much from the solver, but from the API. We'll use the API to generate a cool looking plugin for the editor. So just out of curiosity, how many of you have messed around with Planning.Domains? Any part of it? Yeah, roughly about half. Okay. How many have seen any of the plugins that have gone in just the last couple of weeks? So just these 2 guys, right? So there's going to be a few things that are talked about today that, if you saw what was announced last year, has really changed since then. And so we're ready to sort of take off and bring this to the next level. That's what I'm hoping you guys will take from this and move forward with. So what is the Planning.Domains initiative? This will look a little familiar to those who were at ICAPS last year. It's 3 initiatives. It's 1 platform. It's got a real strong focus on planning problems and its tools for and by the community. So there's been a few of us that have put this together. Moving forward, hopefully it's going to be a lot of us from the planning community putting these tools together for everybody else to use. And it should be special thanks who goes out to the people that helped with this so far, the people that will help going forward, hopefully some of you guys, and the ICAPS organization. We're actually keeping the lights on these servers. So we have funding for 3 years to make sure that everything still runs smoothly. And if it's successful, we'll, I'm sure, continue it. So the 3 different initiatives came from questions that appeared year after year at ICAPS that I went to. Wouldn't it be cool if we had this thing? Usually it was questions at the end of the banquet, we had a lot of beer, and like, yeah, wouldn't it be great if all of our PDDL was in one place? That's what the first thing was about, right? So all of the PDDL files, we collected it and put it into one central place. At the moment, it's just classical planning problems, but we're moving it towards all of the other types. So we brought in all of the different IPCs, put it in a central repository. It's very flat and difficult to navigate where the planning problems are that you're looking for. And so because of that, we also have an API that's built on top of this. And this is what I'll talk about mostly for today, the API part of this. So the API has access for collections, which is just a set of domains, which is just a set of problems, and then each individual problem. And for problems, now it's just a database, we can store statistics. And so you can ask things like, what is the best known lower bound for this particular problem from this domain in this IPC? Right? What is the best known upper bound, or the best plan that we have? You can ask questions like, what are all of the problems where we haven't closed the lower bound and the upper bound? So in some way, we don't know what the optimal solution is yet, or we haven't proved that we have the optimal solution. And in fact, that's what we're going to do for our plugin. We're going to have a nice way to visualize what is the gap between the lower bounds and the upper bounds for a particular domain. Right? It also has a Python library and a command line utility. I'm not going to talk about this, but it is quite extensive and it sort of covers all of the stuff you can do in the API. You can also do with the Python library. Right? So most of what we're going to see today is just sort of the JSON, the RESTful API access that you can use to get information out of this. But there is a Python library for all of the interface and then a command line utility to sort of interact with it. There's also a JavaScript library, so in just a couple lines of code, if you want to put on your website, here's a collection of planning domains for people to see. For example, running the unsolvability IPC, we're going to just put up a new collection, have a couple lines of JavaScript, and there you have the full collection of the different domains we use for the IPC. So very quick access to that. The second big question that was asked quite often is, wouldn't it be cool if we had a planner in the cloud? And this is just more for fun at the start, but just send in a bunch of PDDL and get back the solutions. And this has actually proved out to be very, very useful for some people outside of the planning community who still want to use planners. So we have a solver in the cloud. You can call it with an API, either URL, you give the domain in the problem file, or you just send JSON payloads of PDDL to it. Right? So you create your domain PDDL, your problem PDDL, you send it over the internet, and you get back the solution. And the solution gives you the list of actions, but it also at the moment gives you the ground actions if it's able to ground them individually. So you can see what each action looks like. And we'll see this example later on. But beyond that, you know, because ICAPS isn't paying tons of money for this, we limit what you can do with the solver, right? You only have 500 megabytes, 10 seconds, and that's it. So if you want a little more resources to run your own thing, it's also an open source project, so you can clone this, put your own solver in the cloud. If you have a Heroku account, if you know what that is, the instructions on how to do this, you get there in under 60 seconds. It's really, really quick to redeploy the exact same solver, change the limits, and then you can just use it yourself. And finally, it's also an ultra agile contest. So we want the fastest solver because we only give 10 seconds for people to solve the problems with this. And so in a couple of weeks, we're going to kick off the first ultra agile contest using some of the competitors from the last agile track. And the best one is going to be kept on the website as sort of king of the hill, fastest planner on the planet. This is a little different than agile track or IPCs in that with just 10 seconds, if your parser is taking all its time to do smart stuff in advance, you're going to lose. You need to be very quick to parse things, get quick solutions. Forget about the larger, harder problems. That's not what this is meant for, not with the 10-second limit. So the final thing is, wouldn't it be cool if we had a dedicated editor for PDDL? So I don't know about you guys, but I would always try and do color coding based on OCaml or Lisp or something to try and get the nice, semi-nice syntax, matching brackets, that sort of thing. But there wasn't anything really dedicated for PDDL. And so that's where we took this. It's an online editor. It's using somebody else's editor framework for it, so we get all of the nice updates that comes with it. Multiple tabs is built in, syntax highlighting, custom to PDDL. So if you put :action, it especially colors it because that's special in PDDL. We also have bracket folding, which is extremely helpful when you have actions that have thousands of conditional effects like some of my domains do. You want to just fold it and then have a bunch of stuff represented in here, so it can be very, very useful in some of these domains. Auto-completion, so special snippets that you can start typing the word action, and then it will fill out the action schema for you. You can start typing domain, and it will fill out the full domain structure for you, just to very quickly get the skeleton stuff that you're always copying and pasting anyway. You can also save and load files locally, and because we have these other services, we've included the API to import any of the planning problems from the previous IPCs or any problem that's out there. Right? So you just navigate through, you import the domain and problem file, and it's right there in your editor. You can compute plans using the online solver, and we show the output of the plan in a nice way. Here's the ground action that I was telling you, right? It fills in the parameters and it shows you what the ground action is doing. And also analyze things using Torchlight, which is a tool Uwe Kaufman wrote to sort of analyze structures of classical planning problems. Now this was sort of what the state of the art was last year. What we ended up doing was taking these three things and then adding some extra stuff, pulling them out and putting them back in as plugins. And so what a lot of today is going to be focused on is this plugin architecture for the editor, right? And the API for the plugin architecture. So you can write your own sort of interface and architecture on top of this PDDL editor. And so things from analyzing Torchlight or Complete Solver, which are full-featured plugins that sort of create new tabs and have special interfaces, down to the smaller things like auto-completion. You can just insert little snippets, and so your plugin can just be a set of snippets that allow you to auto-complete things a lot faster for your type of planning problems.
So, sorry,
yeah.
This editor is only online, or you plan?
This editor is only online. Yeah, that's right.
You don't plan to make a standalone version or offline music?
So some of the things can be brought off as the standalone. It uses a common standard for the syntax highlighting, for example. We do have some demand to try and make the editor off all of these offline, well, not the solver, you can run your own solvers offline. But you want the editor offline so you can quickly prototype plugins while you're on an airplane. This is what Nir told me, right? You want it to work on it, but the way it works, it has to fetch the different things. So we are going to try and do a standalone editor, but it's a little less of a priority than a standalone API. A lot of people have problems using the API because in very nice 10 lines you can say, go through all of the strict IPC domains that make sense to experiment on, and you get the domain and problem paths like perfectly done and ready for you. But you need online access for it, and people run tests on clusters that don't have online access. They need to SCP all their stuff over, right? So being able to sort of encapsulate part of the API to put in an offline place, that's more of a higher priority for us at the moment. Yeah. But yeah, the editor is just mainly online at the moment.
But everything is open source, so it yet, or not?
I should put a license on it. Up until just a couple of weeks ago, the code for the editor was minified and scrambled. Now it's open, you can read it. Yeah, anybody can try and save it and bring it down. I mean, the code to run the editor itself isn't open source, but yeah, there's no reason why it shouldn't be. So are there any other questions? It's a good place to sort of stop and take any that you may have. So what are we at? Already 7 minutes late, right? So on the outline, the information sheet that you have here, you know, feel free to take out your laptop and play along. Right? You don't just need to sit and watch the slides one after another. This is meant to be, I'll have a lot of demo stuff and you can mess around with the APIs yourself. There's instructions there on the setup. And so if you have a GitHub or a Bitbucket account getting into Cloud9, you just log in with that. And that's what we'll use later on if you want to follow along and create the plugin yourself and, you know, make the changes that you want to see. There's different places here on where to provide feedback for the API, the solver, the editor itself. And what we're going to do now is go through each of these and just show some of the features of each and what the API looks like. And useful resources that will come up later on. Right. So into the API, like I mentioned, you know, there's a fully featured Python interface, there's JavaScript widgets and a command line utility that's really useful just to play around and look and explore the API. I'm not going to talk about any of it, but go check it out. It's hopefully fully documented online. What I am going to talk about is the JSON read and write API. Right? So the very first thing for the API is what makes up a URL that you're going to call. This is the base of every API call, API.Planning.Domains. And if you are following along, you can use GET requests in your browser just to see what happens when you put these in. So you start with API.Planning.Domains. The next step is to put in the format. At the moment, we only have JSON and XML. Hopefully we're going to have a nice web format with a nice front end that displays all the information. You need to find somebody to take up that project. If we're doing a post request, this will be omitted, but that's just a minor detail. So XML or JSON at the moment. Genre, at the moment, there's only one genre, this is classical. But very, very soon there's a lot of demand to put in fonts, there's demand to put in riddle, demand to put in RMPL. So all of these other types of things are going to be put in very soon as their own separate repositories of planning problems, right? Classical planning problems aren't the only type of planning problem out there. After that, you put in collection domain, a problem, possibly with a plural if that's what you're looking for, and from there things change, right? You can get one domain, one collection, one problem, things like that. And we'll see some examples of what it looks like. So before I get into a few of the demos, these are basically what's going to be returned to you. When you ask for a collection, you're going to always see error in the message. If there is an error, the message should tell you what's going on and why it messed up. But if it succeeds, the collection is going to give you an ID, the name of the collection, a description, which is HTML, so be careful how you display it. Strip out the HTML if you want. And then a domain set, and this is just a set of the IDs for the domains. Right? Tags, it's not really used at the moment, but it could be useful in the future. So again, every collection comes with an ID, every domain comes with an ID, and every problem comes with an ID. And that's how you access the individual ones. What does a domain look like? Very, very similar. The domain has an ID, it's got a name, and a description where it comes from. The tags here are a little more important. At the moment, some of them have been tagged with the requirements that are in the PDDL. Right? So you tag a domain with the action costs or the typing, that sort of thing. And we will put more tags in the future. And one thing to note is the domain name is not unique. So there are multiple transport domains because there was multiple years that transport was submitted to optimal or satisficing planning tracks. So really the ID is the unique thing and the name isn't. And one special thing that the collections give you, just to point out, this collection number 12 is special. This, you can go online and debate what should be in collection 12. What it's meant to be is all IPC strips. If you write a paper and you say, I use every strips domain from all of the IPCs, what does that mean? So different people have different interpretations of what that means, and there's rules of thumb and common lore about how to build that set. You should never use the same domain for multiple years in your testing because you're just overfitting to that domain. Right? Certain domains have bugs in it that just make it unsuitable to use. All of the plans are exactly the same, so you're just pumping up wrong statistics. So this is sort of a collection of the domains that have fixed the bugs, that have used the lore to say only use the most recent bug-free domains, that sort of thing. You can go online and debate whether or not a certain domain should be in the set. So here's the big one. What do problems look like. So if you get back a problem, you get a ton of stuff with it. So you have the problem ID, the domain ID, because it's very useful at times to have it, a name of the domain, and the problem file, so you can call it P06. Sometimes in airport, it's like airport K23-whatever. You shouldn't have to figure out all of the weird naming. That's what the API gives you, right? The domain problem pairs can very quickly be pulled out. You get URLs if you want to download those directly. You also get relative paths. So if you're using the command line utility, it takes these relative paths and it builds up the right locations on your own computer. Again, you have some other stuff like tags. We're going to be putting in things like, is this problem unsolvable? Is this problem invertible? Things like that. And if you have any ideas for tags, do let us know. We have lower bound, upper bound, average effective width, and max effective width. This is the notion of classical planning width that Mir Lipovetsky did for his thesis, some really fun stuff. And then descriptions for all of the attributes for a particular problem. Now this is just a starter set. We want to expand this to a lot more. Yeah.
So what is the lower bound and upper bound again?
The lower bound and the upper bound is on the cost of this problem. Yeah, the optimal cost of the plan for this problem. So
if there's loops, the cost will be infinity for upper bound?
but these are classical problems, so there wouldn't be any loops, right? You should be able to get to the goal in just a single sequence of actions. Yeah, but I mean, when we move this to fond, or this is a fond for particular, which your solution is like a branching tree. We need different statistics. The lower bound doesn't make sense anymore, right? So you're going to have different notions, different attributes that are associated with the problem. So again, the starts of any API is API.planning.domains. From there, you put in the type, classical, right? Collections, if you put in plural, you're going to get every collection that exists. And this is just going to return the JSON of every collection, right? The description of it, the domains that are in there, and that sort of thing. Right? If you want an individual one, you get rid of the plural, and you put in the ID that you need. Right? So this is collection 12, and it gives you all of the information for collection 12. We can do domain 12. Do problem 12. So all of these, technically you could list all of the problems, but there's a bunch of them you probably don't want to. All of these are just direct GET requests that get you access to all of these bits of information. The API is fully documented online, and you can do more complicated things like problems, search, open bounds 1, which are all of the problems where your lower bound and your upper bounds do not match one another. So here are the problems where we haven't proven optimality yet. I wouldn't say that this is definitive across the entire ICAPS community yet. We haven't tried to tackle all of these problems one after another. But eventually, this will represent a list of open problems that the community can sort of go to and look at. Hey, we haven't solved this yet. Can I push it a little bit further? They do this in other communities as well. Like, can we close the bound on this job shop scheduling problem and get a prove optimality? Are there any questions on that? That part before we move forward? No. So submitting attributes, I'm not going to spend a lot of time on this because at the moment it's not open for public consumption. But attributes are again like the lower bound, the upper bound, the width. If you have an interesting attribute for a problem that you would like to see, let me know and I give you keys to the kingdom, right? So you have a special token. Your password that's provided by the events for this, and it allows you to write it. We don't want anybody and everybody to be able to just write things to the API because all of our upper bounds would be smashed by somebody trying to spam it, a disgruntled undergrad or something, right? And we are eventually going to get to a system where people can submit things anonymously, and then other people who sort of understand upper bounds can look and like, yeah, that's roughly correct. I know this person. I approve. Or some sort of wiki-like editing approval process, especially for the tags. We want to open that up. But there is an API for you to post changes to collections, domains, problems, specifying stuff. The description, and you'll see this in the API, is sort of a note to the person that gave the attribute in the first place. So if you look at the lower bounds, we have the king of lower bounds, Patrick Haslam, cranking these out on a regular basis. And what he puts in the description is, this came from using this technique on this version of it in this computer or something, right? He has a special string that he recognizes and understands. So if we go back to him and say, I have a plan and it has a cheaper cost than your lower bound, he can trace it back and say, okay, there was a bug with this sort of solver that I was using, that sort of thing. And so if you are putting things in, the description is meant to be a description to the person who generated these. Null attributes, if you're creating these things, it's very useful just to say, look, give me all of the problem IDs where we don't have a lower bound yet. And so that's what Patrick is using to figure out where he needs to focus on next. API tags. And so this, again, isn't open, but this will be the first thing that we open up for write access. So we have a way to get all of the tags, tagging collections, untagging collections, domains, problems, all of that sort of stuff. We would tag things for different reasons. We don't have a lot of reasons yet to tag collections, but domains, we want to tag it with like the requirements that are on it. Problems, we want to tag it with, is it unsatisfiable, or like I mentioned before, invertible, those sorts of things. At the moment, it's a predefined set of tags that we have, but open to suggestions of anything new that should be added to it. Now plans, this is the one special case. There's a get API for plans, so you can use the API path and ask for the plan for a particular problem ID. What you're going to get back is an IPC style plan. Right? One action per line is the standard thing that you output. And you can also post plans. If you think you have a plan for a particular problem ID, you post it, you give the IPC style plan in your email. For the glory, it's kind of record your email and say you were the one that found this plan. Now the solver that we'll see in just a second isn't just a solver in the cloud anymore, it's also a solver and a validator. And so the validator will tell you the cost of the plan that you're submitting. So what happens when you do this, you submit a plan, we send it off to the solver, we ask it to validate, give us the cost, and if it's better than the incumbent that we have, better than the upper bound, then we take the plan that you gave us and we say, huzzah, you've beaten the best. We're now accepting the plan and we're storing your email if you would like for posterity, right? So you found a new upper bound, a new better incumbent plan. No special access is required for this because we trust Val, the software, to validate our plans. If they say it's good, then we know it's not garbage. And so this is open for anybody to submit plans to. Any questions on that stuff? I mean, I could show a few quick things. Classical. These are the tags that we have at the moment. I mean, again, we're tagging things with the individual IPCs that they appeared in, whether or not it's a learning track, whether or not it's an optimal track. We're tagging things based on the requirements that are in the PDDL. Are you using negative preconditions, that sort of thing. Plan 12. Now I need to consult the cheat sheet. What was the API just a minute ago? Getting a plan is a very new feature, so I haven't had it ingrained in my head yet. Watch this be the one thing that's not on the cheat sheet. Yeah. API path problem. Do not have the type of classical. Right? So the plan for problem 12 is just returned as new lines separated instead of action name strings. And so that covers everything that's in the API, and this is the biggest part of it. And unfortunately, if you have any suggestions, today I'm talking about the API for API.Planning.Domains, the API for solver, and the API for editor. It's weird to say the API for API.Planning.Domains. I've got a naming conflict here, but so be it. This API part is the biggest aspect of the three different things, and it's sort of what ties it all together. So next I'm going to go through the solver outline. I'm not going to talk about the open source project or the ultra agile track. I will mention that this project, it doesn't have to be a planner in the cloud. It's set up to sort of compute plans using a planner and parse those plans and return that information. But it's the exact same project that we used to make Torchlight in the cloud and to make the stuff Tutorial 2 guys use in the cloud and all of these different things. So you can put in any binary that sort of works on Linux, run it in the cloud, get that information, and use it as part of a plugin if you want or something like that. So the solver has three main endpoints. You can solve problems, you can validate, or you can solve and validate. You need to specify the domain and problem, either a URL to those domain and problems or the raw PDDL text for it. Just 1 second, my computer thinks it is late at night, and so it automatically cooks itself. Just sleepy time. Okay. Alright. So if you are using URLs, you need to set the is URL true. Right? So if you're just given a path to the domain problem file, you need to set that. If you are using one of the validates, or if you're using this validate endpoint, then you should give the plan in IPC format. It's pretty common stuff that you would expect to see. What gets returned, we get the length of the plan, the number of actions, the output of the planner, just the raw output itself, the parse status, so it tries to parse the problem and see if it's okay. The type is either going to be simple or full, and this sort of dictates what the plan looks like. In the next slide, I'll show what the plan looks like when it's returned. If val is called, so if you use plan and validate, solve and validate, or validate itself, you get the costs, you get the val output, its area, that sort of stuff. So it also can be used as just val in the cloud if you want, just a remote validator. And this can be good if you've ever tried to compile val. You might have some issues on a lot of machines, right? So it's good that somebody's compiled it for you and put it somewhere that you can just call. Right? So these are what the plans look like. If it's full, it means an extra part of this process was able to parse the plan, ground the original problem file, and then sort of fill in the parameters to give you ground actions. So if it's full, you're going to get an array of objects, names, and actions. Right? The action itself is going to be the fully ground operator. So colon action, the parameters are this, the preconditions are that, and then the name is just the individual name of that action. And so you get one of these for every action in your plan, in order. If we were unable to ground this, if we were unable to get this full parsing done, it's just going to return a simple one, which is just the list of actions. So this is how you can use it. Now, when I say originally this was just, it'd be cool, it'd be fun, but people are using this when they don't want to necessarily have to figure out how to download, compile, install planners on embedded systems and things like that that still do have internet access. Since last year we have over 14,000 plan calls, trying to figure out where people are calling it from. There's a group of guys in Italy doing something. I know there's people in Australia doing something with it. And mainly they're just using it as a service because they don't want to run the planners themselves. And they just have small problems, replans that happen online with their robots, and they're using this as a service to get those plans out of it. So again, demo. So if you go to the solver.planning.domains, you'll see all of the stuff that's there. The API is described. The open source project is listed. There's info about the Agile contest. There's a few online things as well. So this is a quick page that's set up to use the solver. And so if you clone the project, you'll have this list as well. I mean, it's using the API that we saw. So you can click through the different things. This is the description of the API. I said it was in HTML, so you could display it nicely on a web page. You can select the domain, you can select the problem. Lower bound, upper bound, solve. And this is sort of what gets returned, right? So we just print out the list of actions, and this is the output of the planner that's actually running in the cloud. Yeah.
So which planner was used for solvers?
BFSF. Actually, it's SU, then BFSF. So it's a particular configuration of the LabCats lightweight planning toolkit one. It's one that I've had a hand in making, so I know how it works, and it's very, very quick. So that's why it's there. It's very quick and very dirty. If it's a larger planning problem, it's not going to solve it. But for the smaller ones, it can do it very, very fast. There's also, if you're cloning this repository to put your own planners in the cloud, there's a test one. If you're dealing with classical problems, so this is what happens. The server is set up to only accept one request at a time. Right? And if the server is busy, when you ask for a plan, it's going to say the server is busy. So if you really want to have your own private access to something, that's why the open source project exists. You can clone it and you will get the exact same setup that solver.planning.domains has. And you just have your own custom URL. And that server will only be busy if you make it busy. Right? So what's happening here is somebody is calling the server for longer than normal planning times. So now we get it. Somebody else might make a call. Maybe they're getting the server is busy. Maybe the robot is stuttering because it's not getting a plan at the moment. But such is life with free and open services. And so this is the JavaScript that sort of gets returned like I said, you get your result object, you have your cost here. I don't know. There we go. Right. The log path, the plan, it was able to parse it, so each one of these is the name, the action. Right. So if you click on the action, that's the ground action that you get. You know, it sort of fills everything in for you with the ground objects that it's using. So it can be useful to sort of understand what your plan is doing. We've had a request just recently, I think a very good request, that they also want the state, the initial state, the next state, all the way to the final state where the goal holds. They're interested in seeing that as well, so that will be added to the what gets returned. Cool. Any other questions about the solver? The solver in the cloud? I mean, the open source project should be pretty self-explanatory. There's an executable. It's run with a special small script that limits the time in the memory. And then there's a single Python file that parses it and just dumps JSON. So if you want to do something different, if you have a completely different bit of software that's not a planner, you just change that Python file to parse it any way you want and return a different JSON. Yeah. So on to the editor. The very first thing that we're going to do is demo. We're just putting up a bunch of more slides. Let's take a look at it. So I apologize for the 2 to 3 second delay whenever you load this editor. We're working on it. We'll get it fixed as soon as we can. The editor, as you saw, has tabs along the left. There's shortcut commands that allow you to create tabs, close tabs. Everything is sort of in the help there. You can see special shortcuts that you might want to use. File stuff, new, close, load, save. This is the interface that's using the API to fetch all of the collections. So say we want something from the 2000 IPC, the blocks world, and we want to solve this particular problem. You can import them both. You can close this one because we don't need it. You can hit solve, select what you want. And if you have your own planner in the cloud that you've cloned and you want to use, you just replace this custom planner URL, and that's what's going to be called instead. So if you're tired of other people making the server busy, you can just clone and put your own in there. You hit plan, hopefully it says plan found, and we display it in a nice way in its own tab. So you can click through the different actions in your plan, see what the ground thing looks like, just to get a sense of what's going on in the plan. Some of the other stuff that we mentioned, if you start to type domain and you just insert it, you get the full domain skeleton that starts out. Again, if you start to type action, you have a snippet that auto-expands, you get the full action. There's also iterative action ones, and any other suggestions, we can put them in there pretty quickly. Or you can create a plugin that puts them in there for yourself. And most recently, we have the plugin architecture that is what I'm going to be talking about pretty much for the rest of today. And so I told you I pulled out the solver as its own plugin. Torchlight is its own plugin as well. SDAC stands for State-Dependent Action Cost. Yeah. It's a plugin that allows you to compile problems with state-dependent action costs into a regular planning problem that can be used for any cost-optimal planner. So that's a plugin that, if you guys want to stick around for tutorial 2, they'll highlight there. Torchlight and MISC PDDL generators. So for the ICAPS contest yesterday, we created a plugin that sort of allows us to insert PDDL very quickly. These are enable disable things. So you can see if I disable the solver, we lose it off the menu up there. What this new plugin does is create this insert thing, and you can do things like, hey, I need all of the numbers, 1 to 10, I want to call them num, whatever, successors, predecessors, sum, insert, and so automatically you have generated all of these. The predecessor of number 8 is number 7, the successor of number 6 is number 7, the sum of number 2 and number 3 is number 5, so you get all of these things precompiled for free. There's things that will auto-generate grids for you, directed and undirected, things that generate networks. You put in the adjacency list and it's going to generate the network for you very quickly. And custom, it's just an arbitrary box where you can put in JavaScript. A couple of for loops generates all of the action steps that you need. Yeah.
Was that plugin available yesterday?
Was this available yesterday? It was. I made it available 3 days ago.
Oh, okay. Yeah. So it's been very useful for my team too, but I didn't know.
I was wondering, like, should I disable editor.planning.domains? I don't want the other teams to steal all of our good stuff, you know. It was available yesterday, and yeah, there was grids in the problem set yesterday.
Yeah, exactly.
One thing that we found, and this I think speaks to the ICAPS contest, is we had to insert the grid, and I didn't have this directed button up here. Right? Directed and undirected, every grid that we were generating was directed, and then you'd have to copy and paste and make all the errors that this is trying to avoid. So we modified this very quickly, and so you get it right once, and then there's no more copy-paste errors. If you've modeled a lot of domains, you would recall that if you're making a grid, there's two ways to do it. The decomposed means you represent x coordinates and y coordinates as separate objects. And then when you have two grid locations, you have four parameters, x1, y1, x2, y2. So those four parameters are good if you want to model things in a particular way. The monolithic has a single object for location. And the reason why we have both here is depending on what heuristic you use, is it to be relaxed or not, you would want a different choice. Right? So one would give you the handing distance, the other would give you the actual answer. And so you get to pick monolithic or decomposed objects, pick your grid size, location. You can call it link, connected, whatever you want. Insert it, and then you've got your grid all set up. Right? So these are a set of plugins that were created for the contest just before. Last Thursday, I think, we put it through. Oh, and of course, all of my PDDL editing happens in nighttime mode, so we have all of the nice syntax highlighted. Hey, Pedro, want to grab a package? Or papers, yeah. So that's sort of what the editor is capable of, and very recently it's capable of you to generate your own plugins, and that's where we're going to go from here for the rest of the demo. So this is the skeleton of a plugin. This is where you start if you want to create your own plugin for the editor. You need to define a few things. This is still in flux. Somebody had a very good idea that they want an icon for their plugin. So the timeline one that I might demo in a second has a very nice little icon that he's got for it. So maybe a URL to your icon is going to be added here. Other things as well as it comes up. The main functions that you need to define are initialize. What happens when your plugin is first initialized, or every time that somebody drags that enable button in. Disable. It's the opposite. So if you're adding menu items, when you disable, you should remove those menu items, just to be a good citizen. Save and load. This allows you to save the state of your plugin and load the state of your plugin if it was saved previously. Why is this interesting? Well, we found that you might want to configure your plugin in a particular way. If you're using the solver plugin, you've set the solver to your own custom URL. If you hit save on the plugin editor, I'll show you what happens. All right, so if we hit save plugins, what it's going to do, just to make this point a little more, solver foo, it's of course going to fail with an error, malformed URL. And then we say save the plugins. It's going to give you a JavaScript file that you can, come on. Go off script. It gives you a JavaScript file that sort of saves the state of all of the plugins that you have enabled and allows you to load it again as a plugin itself. So this is what's called a meta plugin. We'll see it on the next slide. I apologize for the bad syntax highlighting. But it saved the state of the NIST PDDL generator. It saved the state of the solver. You can see foo is in there now. So that's part of what gets saved when you save a solver. And this allows you to load up the plugin, configure it the way you want, hit save, and then all of those plugins that you've configured and loaded and installed can be represented as a single plugin. You just put this JavaScript file somewhere that you need, and then load that one, and it will make the editor exactly the way you want. And so this is useful, for example, when I want to load just the temporal aspects of editor.planning.domains. So we go plugins here, HTTP, editor.planning.domains. Plugins, temporal. Let's try that. You hit install. So it loads the timeline viewer, it loads the temporal setup, and this does a few things. It hijacks the solve method. So when you hit solve, it's going to a temporal solver, which I think is optic at the moment, right? So it's a different URL that I've created. And when the answer comes back, it doesn't create that solve plan output. It tries to modify this timeline view, and it shows you the plan that you have there. So again, this is the timeline viewer that somebody else created as a plugin just 2 weeks ago. And so it gives you a Gantt chart type thing of the temporal problem that you have. So this loads temporal.js. Again, it's an example of a meta plugin that sort of loads everything and configures it the way that I want. So the save and load can be extremely powerful, and this is what the meta plugin looks like. You set meta equal to true, and then you just have a dictionary mapping all the different plugins and the settings for those plugins. Again, sometimes you might want to write this yourself. Sometimes you just hit save, and it saves the state of everything for you. And that's how I've used it most of the time so far. So what API can you use if you're writing a plugin? What do you have access to sort of get your hands into the editor and change things? Well, for the menu interface, the buttons across the top, you can add a new menu, which is the drop down at the top. You can add and remove menus or buttons. You need to specify things like the name, the ID, the icon. And so the icon itself, on your info sheet, there's a link to glyph icons. So these are just a big set of different icons that you can use. Pick the one that fits the best or change it to whatever you want. The one thing that's of interest here is if you add a menu button, you need to give the parent menu if it's underneath something, but also a callback string. This is the string that you write to the JavaScript function that's going to be called. We'll see this in practice in the second half. And so this is what's called when you click that button, and that sort of initializes your plugin. You can create new tabs. So this is the interface for creating a new tab that's along the left inside of the editor. When you create a new tab, you need to give it a name. This is like unnamed one.pddl, whatever it might be. The callback is a function that you pass in that's going to be called whenever it's done. So this is an example of creating a new tab. You call it my tab. The function, this is the second parameter. The function that you want called is going to be given editor name. And so this is an ID in HTML that allows you to fill it. So we just say, hey, I'm in a tab, and you can add it there using jQuery. So I should take a pause at this point. Originally, when I put the call out for a practice version of this tutorial, I told people you sort of need to know PDDL when you're coming into this. It turns out that you don't really need to know as much PDDL as JavaScript and sort of RESTful APIs. And so I apologize if a lot of this is just sort of flowing over. You've never seen JavaScript or HTML before. There's going to be a lot of that from this point forward. And so this is the JavaScript that you would use to insert a bunch of HTML inside of a new editor tab that you have. And this is what we use for creating the new plans, or creating the timeline view, all of that sort of stuff. Now, code snippets. This is the thing where you start to type domain and then hit enter, and it gives you the entire skeleton. You can write your own code snippet, and that's again another one of the resources at the bottom of your info sheet. It uses a Cloud9 style of code snippet. So what this does is it says, once you're done typing it, I want you to put the cursor here at number 1, and this is going to be the default. Right? So they can overwrite what that is, and then you put the cursor at number 2. So just to see where it goes, at the editor here, and I start to type action. It's a snippet, and the cursor immediately goes to where that number 1 is going to be, and that's action name. So immediately you can start typing the action name, foo, and it replaces what's there. And if you were to hit tab, it goes to the second one, the third one, and so on. So it can be very powerful, and you can create complex code snippets if that's what you want to do. The file chooser, so when you saw solving a problem, it brings up a little dialog that says select the domain, select the problem. You can interface with this file chooser. I'm not going to go into detail about this, but you register as I am a plugin that needs to be choosing files, and you can sort of make changes to what that dialog looks like inside of the file chooser. This allows you to already have access to something that brings up the modal dialog saying, hey, I need 2 files in order to do what it is that I do. Injecting styles, if you need CSS to make things look pretty, and everybody wants to make things look pretty, that's how you do it. And finally, we've got this little toaster at the bottom, the little messages that you see popping up when different things happen. That's a window.toaster success info warning error, so you can put messages to the user as they're using your plugin. Cool, so that was a whirlwind. I've almost lost my voice, but we're good to move on to the second part. So this sort of covers all of the different APIs. The API for the API for the salt for the API for the editor. And from this point forward, we're going to create a plugin from scratch that uses the API for the API and the editor API. And so it will be a plugin that shows you the difference in bounds from bottom to top. We are not so far off time, so we can take a few minutes if people want to grab a drink of water. I know I want to grab a drink of water. Have a break, set up your laptop, that sort of thing. So I should mention, if you guys are interested in contributing to any part of this, it is by all means completely open for people to hop on board. There's a group, a team on Bitbucket called Planning Researchers, and this is where we're starting to put things into. And so under Planning Researchers, there's a number of projects. Benchmarks has only one, that's the set of classical benchmarks. But like I said, Riddle and Fond and all of those other things are going to start appearing under that benchmarks project. The editor plugins, we already have 3 or 4 that's gone up there. You've seen most of them already today. IPC tools, as soon as the unsolvability track results are announced, Nir and I are going to put all of the scripts and stuff that we wrote into the IPC tools, and we're going to ask all the previous IPC runners to put their tools up there as well, make it easier going forward. Planning tools, some random stuff that helps people with planning. And resources, things like tutorials, in particular this tutorial. So I think it's on the info sheet in the instructions on how to set up Cloud9, but everything here in this Planning.Domains tutorial is inside of this repository. So in here in resources, you'll find the cheat sheet you have, the info sheet, the slides, the tutorial plugin that we're going to be creating, and then the other stuff to sort of get started with what we're going to do in the second half. So all of this information is up and available for you guys to use. Wait just another second. Are there any questions? I should also say that having come to the tutorial, you are the first and #1 folks that have my ear as to what should go into this. So any requests, feature requests, bug requests, anything like that for any of the 3 initiatives, you guys have top priority. Yeah?
I have a question about the editor. Does it have a plugin for Valve already?
Does it have a what, sorry?
A plugin for Valve, the validator? Because there isn't an
Yeah.
output from Valve there, right?
It's a good point. No, it doesn't. No, it doesn't. So how would you envision it? You give a plan and you say, Val, here's 3 files that's made a problem in the plan. Tell me what you think.
Exactly. You give these 3 files and then the output is similar to the
solver.
The solver output
yeah.
that you show.
So the solver one, we are gradually making it better, right? So if we go back here, let me import very quickly something that I can solve. Blocks. Import, solve, both. So until very recently, you did not have information on the output of the plan, but now you can click output. Even if it solves it fine, you want to see what's going on. And so the guys for tutorial 2 said we need the plan cost. We care about the optimal plan cost, but that wasn't being parsed out. So I think the next step might be to solve the plan tab should show the cost of the plan, not just the length of the plan, which it doesn't even show at the moment. You have to count the number of actions, right? So that val information, yeah, should be put in there. Because val is quick, so I can call val, solve and validate. Yeah. But good idea. I'll put in a plugin for just val button. Here's the plan. Tell me what you got. Yep.
So this may become more as important when you go into forms or numerical other aspects of planning.
Yeah.
But just like you have the drop down for choosing the domain or column, I'm wondering if it may make sense to have a drop down for the possible solvers for a particular domain.
Yeah.
Well, they can have a default, but sometimes when you have to run experiments, for example, for the gateway, you want to try multiple.
Exactly. So during the ICAPS contest, I figured Nir and I, we're bright guys. We'll crank through these domains in just like 3 or 4 hours, and then we'll spend the rest of the time making it look pretty. It didn't happen. We didn't get anywhere close. But the idea was we were going to create a solve functionality that says not just this solver, but all of these solvers, and show me the difference between them. Like, what are the planning lengths of each of the solvers that ran? Show me the outputs of each of the solvers. So it's not solver in the cloud, it's solvers in the cloud. Yeah, so that's something we definitely want to do. Tiago's It's Simple program did a very good job of this at showing statistics about different planners and how they operated on that thing. And so that's something we definitely want to pull over. But bringing it up means there's just 1 extra vote for it, so this will be something we work on sooner. Are there any other wish lists?
Vim plugin for the editor.
A what?
Vim? so that you have
Vim
Vim
plugin.
shortcuts.
Nir asked me yesterday for an Emacs one, so. I think that, you know, when you're doing development and stuff, sometimes somebody asks for something and it sounds like it's a really big thing and it's just a couple of lines of extra code. And it's like, yes. Sometimes they ask for something and it's extremely simple sounding, but it would take a complete rewrite. Right? So, for example, when you'll see this as a pain point. When we're creating this plugin, if you want to make a change and see what happens, reload it and see it, you need to refresh the entire page. And that initial 3 seconds of an infinity animation going is the most frustrating thing you'll find. So the very simple thing of just saying, hey, reload this plugin, it's a very difficult problem to do. And I don't want to necessarily go forward with it because it would put a lot of the onus on the plugin writers. And I want to make that as easy as possible for you guys. And so we're trying to figure out how to set it up better for plugin. We need like an editor for plugins. Right? This is sort of a framework for making these. Very simple sounding thing, very complicated to do. A very complicated sounding thing, so automatically could be complicated. Adding Vim or Emacs. Because I'm based off of the ACE editor, which is a full featured thing, I'm pretty sure there's already Vim and Emacs modes. I just need to expose that to the user, and so it'll be a very simple, click, 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 1 or 2 lines, and you've got your Vim access. Yeah. I'll let you think about it until the end of the session, and I'll take any wish list requests. Those will be the first ones that we work on. Alright. So if you're following along at home, load up Cloud9 or anything else that you would like. The reason why I'm suggesting Cloud9 is because you need to put your plugin on a remote server, and Cloud9 allows you to do this with just a couple clicks of the mouse, which is nice. You need to have the URL for your JavaScript file that we're creating at the moment. So I will do this as it should be done, as it could be done with you guys here. So we're going to call this my tutorial for Planning.Domains. Doesn't matter what I call it on the description. It needs to be public because you need access from this to the editor. Now you're going to clone from an existing repository, and the URL to use is on the info sheet. You can also get it here. Important thing, if you're on Bitbucket and you're looking at this, don't use the git URL, use the HTTPS. This is the URL that you're going to use to clone this repository and get going. And if I paid for Cloud9, this would be instantaneous too, of course. ICAPS doesn't pay me to pay for Cloud9. So if you've loaded this up, what you do in Cloud9 is bring up the example HTML, hit run. And what it is doing in the background is creating a tiny Apache server that allows you to visit this URL. Strip the HTTPS just for good measure, and this is what you get. It'll complain about the JavaScript library. That's because we just updated the API version number. It's been bumped to 0.2 with all the cool new stuff. If you see this, it means your Cloud9 plugin is working. So the URL, tutorial-pd-has, this is for my own personal plugin. And so, I mean, if you're doing this yourself on your own plugin, you're going to have a different URL, and that's the one that you use. Now, if you have access to example.html, you should also be able to replace that with plugin.js. And this is the skeleton of the plugin that you saw on an earlier slide. Right? This is where you start if you're creating a plugin. This is what it looks like. And so this is the URL that we'll be using for your plugin. Now, one nice little feature of the editor that we put in to make things a little bit easier is if you put editor.planning.domains and then a hash after the slash, this allows you to automatically load a single plugin that's after that hash. And this is extremely useful if you're creating a plugin from scratch and you're reloading again and again. So instead of going to install a plugin, pasting the URL, hitting install, and all of that sort of stuff, you can just put it up there. And so personally what I like to do is take this URL drag it down here as a bookmark. And so whenever I need to reload things, you just click on that link and it's going to reload your plugin. Solver comes by default. The Planning.Domains 1000 is the next thing that loads. If you've gotten to this point, you're 90% of the way there for having your own plugin. You're already on Cloud9, you're running the Apache server, the plugin exists at a URL, and you've automatically loaded it for this. Cool. All of that's just sort of how to get set up so that you can follow along and do this on your own. And this is the sort of workflow that I use as well. Alright, so we're going to make this big. We're going to do a few things here, like call this the bound viz. My name is not John Smith. What did I say? Mr. Fancy Pants. That's my name. Mr. Fancy Pants is the one who did this. Yeah, right.com works. Shows the difference in bounds. And so, you know, instead of plugin initialized, we can say, or disabled, we can use the window.toaster. Warning, that's a good one. Okay. Nobody should disable our plugin. And so now again, what you should see is that it's no longer the Plugin-matic 1000, it's the bound visor. Okay. It's automatically loaded up for us, so inside of the plugins here, you should see it at the top. Solver and bound visor, this is where the info is shown. If you disable it, you've got that poor sad little toaster along the bottom. Okay. So cool, now we have a plugin that's loadable, it's doing stuff, and we're well on our way. Are there any questions? So basically these are the four main functions that we're going to fill in. As I was doing the different plugins, usually what happens is the save, you sort of save the state of the variables that would allow you to configure this plugin. The load, you just do the exact opposite. The initialize and disable is usually spent creating menu items and removing the menu items from the top list if you need it. And then everything else is code that you put above. So you define your own functions to do whatever it is that you want to do. Create new tabs, display new stuff, all of that sort of thing. So the next thing that we're going to do is create and destroy our menu items. So under initialize, let's do a window.add menu button. We'll call this viz menu item. Now the second parameter is an ID. This is an HTML ID, so you can refer to it later, get rid of it, use it for other parts in your code, that sort of thing. You need a way to refer to it. And then glyph, icon, signal. Finally, launch viz is what I want you to call it. So I'll bring up just quickly that bootstrap link that I gave you. These are all of the icons. And so what it's expecting is sort of not the glyph icon, but the glyph icon, OK circle, glyph icon, remove circle. You can pick any one of these that you want, and it will insert the icon for you. They have a fairly large list, so you can play around, find the one that you like, and put it in. So back into here, we've added it. What we want is when you click on this menu button, launch viz is the function that we call. And so function launch viz, it's as simple as this. And again, we'll do a window toaster success. And so in the initialize, we're adding the menu button. So to be a good citizen, in the disable, we should remove the menu button. Window.remove. We may have a mismatch here. We'll see if it works. All the changes are saved. Go back over here. For whatever reason in Chrome, you need to double click. I don't know what's going on. So here we have our new menu button up at the top, viz. Right? We've got our little icon, the signal one that we want to set up. We can click it. it says huzzah. When we disable it, it asks where are you going, and it removes it from the top. So this is just being a good citizen. If somebody enables your plugin, you should show the interface or change it if that's what your plugin does. If they disable it, you should remove it next time. If you do something like hijack what the solve button does, so your plugin relies on another plugin, you should do some extra stuff. Make sure that the solve plugin is installed in the first place. If you do hijack, then set it back the way it was before you're done. That sort of thing. So just make sure that you're initializing your disabled functions. Sort of do the opposite of one another. Don't be too destructive. So the next thing that we might do, let's show what happens with saving things. So initial setup, this gets run once, the very first time that your plugin is loaded. You can initialize variables that you might want. So for example, in the bound visualizer, we're going to have a domain ID that we're visualizing. We want to save this domain ID for future use, let's say. So we'll call it domain ID equals 13. It's my favorite number. And then in the save functionality, we want to say that the domain ID is going to be saved from whatever the biz domain ID is set to. And the load functionality, what's going to be given here, the settings that is passed into load, is exactly the same thing that's returned from the save function. Okay? And so what we want is just the opposite. Window does. This domain ID is going to be set to the settings DID. And just so we actually have access to do something here, we'll just very quickly in a JavaScript way prompt the user the domain ID. There's nothing special about this. It's simply how JavaScript allows you to put up a little prompt and ask for some input from the user. So we're going to ask the user, what domain do you care about? We're going to make that setting, whatever it is that they respond, and then we should be able to save it for later use. There we go. 13 is the default one that comes up. We put in 26. Hopefully it's saved. So biz domain ID, and sometimes it doesn't work. We are still trying to debug what is happening here, but every once in a while it could be that the code is wrong, but things just don't get saved to the window in the way that you would expect it. So if we hit biz 26, biz again should show 26, and the biz domain ID. So now I would suspect something with the code. Any thoughts? Looks good to me. So if we hit save, load up the new one that we just downloaded, it is coming back as null. Of course, demos never work when you actually want them to, right? Biz domain ID. And now it magically works. So again, the plugin infrastructure is less than 3 weeks old, and so we are still trying to figure out what exactly is going on. But the code seems to be correct. We just need to refresh 3 times before things kick in. So now we have it saving, right? So if I was to once again go to plugins, hit save, we would expect this new plugin here to save our domain ID to 26. So we could load this up again. We could put this meta plugin anywhere online, and when we load it up, domain ID is going to be set to 26. So this is just a very simple example of how we do deal with settings. There's nothing really complicated about it. Nothing really complicated or interesting, just to show you that it can be done. So the next thing that we'll do is load stuff from the API. So this is the first time where we're actually going to go back and use the API, not the editor API. So back up here, we've gotten from the user what the domain ID should be. Now we want to load all of the problems for that domain ID. We want access to that database, that information for each of the problems in there. And so using the JSON API that we have, right, we build our URL. Everything starts with api.planning.domains. We want it to be JSON. We care about classical. We want a set of problems. And what we're going to put in, if you look at the API syntax, is the domain ID. So this is the URL that will get us all of the problems for this particular domain. And just to confirm what's going on, you could copy this, check in a new tab, say 13 is what we're looking for. And indeed what it's returning is a list of problem objects like we saw before. And every problem object is going to contain this lower bound and this upper bound. And so here we have a JSON request. This is using jQuery to very easily call a JSON get request and get it back, press it, deal with it later. So the first parameter is the URL that we're calling. We've built our URL properly here. The second parameter is going to be a function that takes the result and does something with it. And again, I apologize if you haven't done a lot of JavaScript coding. A lot of it looks like this. You're passing functions around with functions and functions as parameters for functions. It takes a while to get your head around, but this is what the syntax looks like, and all of the examples you'll see on them is sort of the same. So now, when we get this, res is going to be the results that we get back from the API. And so we can say if there was an error, maybe we want to say window.toaster error, whatever the error message was. Otherwise, we're golden and we're ready to go. So, for example, let's just very quickly say window toaster problems loaded. That's not an error, of course. That's info, success, whatever color you want it to be. And then we'll just console.log dump all of this so we can take a look at it. And so, I mean, here we're just making a simple call to the API, given the domain ID we have, and then we deal with it different ways. If there was an error, then let's figure out what happened. If there wasn't an error, we'll move forward from there. So if we hit viz, hit 13, the problems load very quickly. Right? And in here we have the object stuff that we've got. So error false, message success, and inside of here we have an array. Every object is going to be our problem object. And we have access now to all of the statistics that we need. Cool. $15 minutes, right? So I think at this point we'll do one more thing, right? So I'm going to show you how to create a new tab, how it sort of looks here, insert styles if you want CSS to make your tab not look really crappy. And then from that point, we always have the fail-safe. Let's copy the complete code over to see what it looks like as the finished product. I'm not going to hold you guys later than promised on the schedule. So once we have success, we want to display this in a new tab. We've got our data. We want to make it look pretty and actually load it up. And so the first thing that we might want is down here when we initialize, we could use the inject styles button, or the inject styles function, to put in some basic CSS. So say we're going to have a class viz display. And you can add anything else that you would want in CSS, just your chunk of stuff to make things look pretty. And then, once we have a successful return, we are going to create a new tab. So window, new tab. The first thing that you can do, and this is common for something that creates multiple tabs every time that you call it, is you want a name for your tab. So let's call this the bound viz tab. And for a little bit of information, let's put in the domain ID, just so we know what's being displayed in that tab. So we already have the domain ID that was pulled in from the user's input. What we pass to the new tab function, what's it come down a little here?
Missing a plus.
Thank you. You pass in the tab name, and then again, you have the function callback. That's going to give you an editor name, and then you fill in what happens. So this is the API for creating new tabs that will come along the side. You pass in what you want to call it. This editor name is it's an ID actually, not a name, and this allows you to throw in the HTML for that new tab. So what we're going to do is populate the HTML with the new tab that was just created. That's called bound viz, whatever the domain ID is in brackets. So typically I would start like this. We wanted to style things a little bit, so we call this class viz display. And H2, we want to say this is lower, upper bound comparison for a particular domain. So let's get this DOM name in just a second. Close our H2. Call it a day. Close our div. The final thing that you do is JavaScript or jQuery to say, hey, I've got this ID. It's called editor name, and I want to insert some HTML that I've created. So the one remaining thing here is how do we get the DOM name? If you look at this is the API call to get all of the different problems. Every one of the problems conveniently has a domain setting, which is the name of the domain, transport, block scroll, something like that. So we're just going to pull it out from the very first one that we have. So we say res var DOM name is going to be equal to the res. And it's always useful to look down here to make sure you're calling things correct. Result 0. So result 0, domain should get us the domain name, and it should create that put it in. So we've generated the start of our new tab. Unless I've forgotten plus signs again, let's see what it looks like. So we hit the viz button, we ask for 13, we get bound viz 13, problems are loaded, and this is the lower and the upper bound comparison for transport. So at this point, everything that I've showed you is all of the editor interface for doing it. The rest of the plugin is just dealing with Google APIs to make a chart look pretty, all of that other stuff. So you can use any JavaScript library that's out there, load things dynamically, make things look and behave the way you want. People are going to be creating plugins in the coming weeks for creating networks with the d3.js library that allows you to very nicely and interactively create networks with edges between things attendees, and then it would just generate to the network for you from the visual representation. We use the Google Charts API for this, and we use the Google Charts API for the timeline view. And in particular, the timeline view was something that the guy who wrote it, Steve Levine, had as his own separate JavaScript display for plans. And he spent an afternoon just porting that into a plugin very, very easy. So if you have any projects, and you have any, or students that are working on projects that have a web visualization, it's a straightforward process to port it over to something that works in the plugin architecture. And so, again, with 8 minutes remaining, what I'm going to do is bring up what the full tutorial looks like, the tutorial plugin. So if we look down at the bottom, you know, we've got the settings that are saved, load, you remove things. There's a little bit of extra styles in here that we didn't put in yet. One extra thing that I do is I load the Google Visualization API, and I keep a Boolean flag just to make sure I don't load it too many times. And this is, again, not something that's unique to the editor of Planning.Domains, but is just something that Google offers, right, to put in charts. And so up at the top, we have our launch viz, record the ID, we make our call, print the error if it's there, and then we get the data, we scrub the data in a particular way. Again, nothing particular to the API here, but we go through all of the things. We try to find if it has lower and upper bounds. If both the lower and the upper bound are missing, we don't bother showing anything. It's pointless. And we get a little bit of information. We display, you know, if the lower bound's not there, we'll put question marks, things like that, right? So we're just sort of processing the data to sort of display it better in the chart. The data.push is something from Google. You put things in an array. You add the columns of the array for a particular type of visualization that I'm going to use. Create the options for this, and this is just setting the colors, setting the bar widths, that sort of thing. And then here is the HTML that you saw. You create your new tab. Right? We put the class viz display. We've seen this already. And then here is where it's just inserting the new stuff that Google has. Change document is something that is editor specific. It allows you to force the change to the new tab. It's useful in this example. And then you just create the new chart using Google's API once again. So what does this look like? I'll copy this and replace it all over here. One thing that I don't want is to be Christian Muise anymore. It's Mr. Fancy Pants. Wow. And so now if we reload everything, the bound visualization is loaded. Right. We can close this because we're not creating domains. We load problem 13. So we've got the Google chart for problem 13. And so what it's showing here is the cost along the bottom, and the gap in the bars here is the difference between the lower bounds and the upper bound. And the extra information that we were putting in are tooltips over top of this. So for this particular problem, the lower bound is 410, the upper bound is 3270. For different domains, you can find things like 26. So what we see here is there's very, very tight lower bounds and upper bounds in some of these things. The red ones means that either the lower bound is missing or the upper bound is missing. So here, Patrick has hooked us up with a 275 lower bound, but we haven't found an incumbent plan for it yet. Right? And so here we just have a visual way of indicating that red means that we're missing one of the sides of this. And so from sort of start to finish, we've seen how to create the plugin and give us something that sort of has a nice indication for each of the domains that we're interested in. Cave diving is one of my favorite. I had a hand in making it, and it's difficulty in finding solutions for this. And so this can represent, you know, a source for problems where people can go and focus harder on getting incumbent solutions for or improving the lower bounds, the biggest gaps, that sort of thing. And so I think that's sort of it. Are there any questions about the entire process? How it goes, how it went? Pressure points. I know double-clicking that little link and reloading is a royal pain. I realize that, and we're going to try and figure out ways to make it easier. It takes 3 seconds with the Infinity, no matter what your internet speed is. It's a mandatory 3 seconds. We'll fix it in the future. We'll try to figure out how to load naturally. The reason it's there is because if I don't put that black screen on, the visual elements come in weird ways, especially on a slower connection, and it looks really, really bad. So as soon as we figure that out, it'll be a lot easier. Again, your wish list is going to be the #1 priority. So if you have any other ideas or things that you would like to see easier when you're creating a plugin, let me know. And again, my computer thinks it's sleepy time, so we've gone to yellow. Are there any questions? Oh.
I have one. About the editor again. For example, yesterday during the competition, I was using for a little while the Planning.Domains website. And
I should have disabled it.
oh, but I didn't use it.
If you guys win, I want at least one beer.
Okay,
yeah.
Sure. We're open, don't worry. And when we were modeling one particular domain, and we forgot to add some parameters, right? But the syntax, you have a syntax highlight parser that will check for
certain
usual,
so
but it doesn't check for missing parameters. So when we hit solve, it will the parser will show you, but only one error. It doesn't show all.
Yeah.
So that's
it's a very, very good point. Another thing is some of the domains that you import, they look absolutely horrendous. You need a sort of an auto formatter just to make it look a little prettier. Right? The biggest thing that's missing, and we'll put this in our presentation for the ICAPS thing later this afternoon, the biggest thing that is missing is good diagnostics when you're trying to model the domain. What we really would need, and if anybody here has a lead on it, please let me know, what we really would need is a parser for PDDL written in JavaScript. We have ones written in Python and all the other languages, and so we could do it as a remote call to the server. But what would be really good is if we had a parser that was very strict about what is acceptable and not acceptable in JavaScript, so we can highlight the syntax errors on the fly. The ACE editor, which is what the framework is sort of built on, it supports you to insert things like syntax checkers for your particular language. The language here is PDDL, and that's why we have custom PDDL syntax highlighting. But we haven't gotten around to writing the particular syntax checkers. And a lot of it comes down to you need a parser because you need to know that if you're using a parameter, you're missing it in the parameters for the action schema. And there's a lot of issues if you're trying to debug a domain. Anybody who's tried to model a domain, I'm sure you're aware, you finally get it done. It parses, so it doesn't say that, hey, you're missing a bracket here, but it just says it's unsolvable. That's completely useless, right? So at that point, when your solver says it's unsolvable, you start commenting out actions, you add new fluents to your initial state, and you go one by one till you find it is solvable, and add things back bit by bit till you figure out why. That's a horrible way to do it. We should not accept it anymore, right? So what we're going to push for is to find somebody to create something that says it's unsolvable, and here's the chain of fluents and things that the goal fluent that can't be achieved, and the actions all the way back. And so then very quickly you could diagnose, like, okay, this action didn't have the right precondition, or it's not having the effect it should. And for the temporal problems in particular, we would say unsolvable, and it's probably just because of the temporal, a negative cycle and the temporal constraints, right? But you need to debug it by changing values and inserting things, and it's a waste of time. So that will be the biggest thing, I think, going forward, diagnostics of why your domain is failing. Cool. Are there any other ideas? I know for my group in particular, they're not so interested in PDDL as much as another language, RMPL. And so what we're going to be doing is showing how through plugins you can sort of strip out, replace all of the PDDL stuff from this and put in RMPL. So if you have a different language entirely, but it's still a planning language, a planning problem language, it still should be fully supported, right? You should be able to strip out the syntax highlighting and put in your new syntax highlighting and still get the same sort of interface type thing. And the API, when you hit import, should go to the API for RMPL files, not the PDDL ones. All of that should be turnkey. Okay.
I was just wondering, so for example, one of the things that you said was that in order to be able to use these things, you need to have a fairly good understanding of JavaScript in order to be able to
create them. Yeah.
Exactly.
Yeah.
And then, but for example, if you look at things such as like ROS, you know, they may, even if you don't have a very good understanding of Python or C++ or Rust or basic languages, they provide you a text interface where, for example, if you want to, the message passing, which is a fairly complicated process because you have to create serialization, all of that. But all of that is abstracted out by the text interface, where basically you define the struct using, common sense fields, and then that gets read by something that then generates the code for you. Yeah. So I was just wondering if I mean, if for a lot of the functionality, so if someone is creating a plugin, or if you would have a set of like standard functionality or things, and you can just specify them with common sense English.
Exactly.
That gets read.
So the biggest thing for that is like the Solver open source project. I mean, the guys for tutorial 2, they have something that takes in a domain and problem file and gives you back a new domain and problem file. The original ones are in a special syntax, and the new ones are standard PDDL. So what I would hope to see is, what we're going to try and get to is, if you want to write a plugin that does that, you write what happens in the server, which is your own code, if it's Python, C++, whatever, and have it parsed so that it dumps out the JSON correctly, then have a standard interface for the plugin that just says, hey, this is a converter plugin. I don't want to write anything more than that. Use this icon. It's a converter plugin. You take a domain and problem, you give me back a domain and problem. And have an interface that says, this is converts to this. So exactly that, it'd be very useful. Yeah. But at some point, if you're writing a plugin for the editor, it's an online editor, and you need to put in some HTML or some JavaScript cost in order to get anything shown.
And another thing I was just wondering, can you run these things offline? Why can you kind of like dump these things in?
I'll make that as another vote. So the problem with just having your plugin locally and then loading up a local file is cross-site scripting errors, right? So you can't do it because Google thinks you're trying to hack somebody. We want to get to a point where people might be able to run this editor offline, and we may get there. We hope to get there.
You mentioned tutorial 2. What is this tutorial 2?
Tutorial 2, it's an excellent tutorial. I wish I could be at, but I need to be at, is it for the talk that we're giving. It's going to be on converting problems with state-dependent action costs into problems that are just traditional.
I thought there was another Planning.Domains API.
No. One of these is enough. You guys have had enough. All right, if that's it, thank you very much.
So what is the tutorial slides?
The repository that's on the info sheet, all of these slides and everything is in there and ready to go. Yeah. The plugin from start to finish, all of the slides, the cheat sheet, all of that stuff. Yeah. Thanks guys, thanks for coming out.
Thank you.